We're asked to solve the equation by completing the square. So the first thing we want to look for when we're completing the square is the coefficient that is attached to the variable squared. So that's the first term in the trinomial. It needs to be a 1. And in this case, it is not. So the first thing we want to do is divide this entire equation by 4. And when we do, we get p squared minus 5p plus 23 over 4 equals 0. Now we want to isolate the variables on one side of the equation and put all the numbers on the other side of the equation. So that leaves us with p squared minus 5p equals negative 23 over 4. Now it's time to complete the square. And the way we do that, the steps are: you take the middle term, the number of the middle term, in this case we have negative 5p, so it's negative 5. You divide that number by 2, and then you square it. So in this case we're going to have negative 5 halves, negative 5 divided by 2. Fortunately we can't simplify that, so that's just what it's going to be. Middle term divided by 2, and then we square it. When we get that, we're going to have 25 over 4. And we have an equation again. Quadratic equation. Remember that whatever we do to one side of the equation, we almost always must do to the other. So we also have to add 25/4 to the other side as well. When we factor this out, we're going to get p minus 5 over 2 times p minus 5 halves. And we know that's true because if we FOILed this out, we would end up back with this equation. Over here we have 23/4 plus 25/4, and that leaves us with 2/4. Because these two are identical, we can just write them as 1, p minus 5 halves squared, and 2/4 simplifies down to 1/2. We're solving for p here, but unfortunately we have p squared right now, so the way that we get rid of that is that we want to do the square root of p minus 5 halves squared, but whatever we do to one side of the equation we must do to the other, so we also have to put the square root of 1/2. Now remember that we have something called the square root property, and the square root property tells us that if we have a squared and that equals b, that then a is going to equal plus or minus the square root of b. So we're going to remember that when we solve this. The square root of p minus 5 halves squared is just p minus 5 halves. And then of course we have plus or minus the square root of 1/2. Still trying to solve for p, but we're going to work on this side of the equation for just 1 minute. So the square root of 1/2 is really the square root of 1 over the square root of 2. We have a radical in the denominator here, and we can't, and we don't want to, so we're going to go ahead and get rid of that. And the way we do that is that we multiply the denominator by itself. The square root of 2 is the square root times the square root of 2, Remember that whatever we do to the denominator, we always must do to the numerator as well. So we're going to multiply the square root of 1/2 by square root 2 over square root 2. Now the way this works out, let's just go over this for a quick minute, is that when we have the square root of 2 times the square root of 2, that gives us the square root of 4, and of course we know that that's 2. So we have p minus 5/2 equals plus or minus, we determine that our denominator is going to be 2, numerator square root of 1 is just 1, and multiply that by square root of 2, that leaves us with just square root of 2. Plus or minus stays. Now we can isolate p all by itself on one side of the equation. All we're doing here is subtracting 5/2, so we're just going to add 5/2 to both sides, which leaves us with p equals 5/2 plus or minus square root 2 over 2. I'm just going to go ahead and finish this up right over here. This really is our answer, but we can, because we have a common denominator, we can write it a little bit more clean, so we're going to do that. So we have p equals 5 plus square root 2 over 2 and 5 minus square root 2 over 2, and that is the answer.